In this video, we are going through some examples of simple trusses and solving using both our method of joints and method of sections. So for this first question here, it's always a good rule of thumb, like we said before, to check for zero force members. So think about which ones you could get rid of and still have the structure be maintained. So we have reactions here, and we have a roller here. So because of these two reactions, we can't use them. So there's forces on E and A and C. So if we look at D, we couldn't use, if we got rid of this, that means this would deform, so we can't use that. So that means none of these are zero forces because this still needs to hold it up. And definitely we need this beam here. So kind of just use logic and your spatial reasoning to see if your structure would stay maintained if you got rid of those suspected zero force members. And if so, then they are not zero force members. So we're going to work with each of these and not get rid of anything. Okay, so let's start at A. Actually, no. Let's start at whichever one has the least amount of unknowns. I would start at C. So let's start at pin C. So pin C has force FBC and force FCD, considering them in tension, and we have an external force of 3 kilonewtons. So method of joints means that we develop two equations for each one. So we have two unknowns and two equations, so we can definitely solve for this. So this is equal to, we have FBC negative direction, and we have in our negative direction as well, FCD, and this is going to be our sine, right? No, it's going to be cos, sorry. Cos 30. Okay, so then FBC is equal to negative FCD cos 30. And in our downward direction, we have Fy equal to 0. So this is negative 3 kilonewtons, and minus the y component, which is in our downward direction again. So this FCD sine 30. Okay, and FCD is going to equal, so this is 3, move that over. And sine 30. And we move that negative over, so FCD is equal to, this is 3 over sine 30. It's negative, so it's negative 6 kilonewtons. Or we can just say that this is 6 kilonewtons in compression because it's the opposite direction. So that's compression. And when we put this in for FCD, so FCD is negative 6 minus negative 6 times cos 30. And this is 5.19 positive, 5.196. Okay, and this is our answer. This is in kilonewtons and it's positive, so this is in tension. Okay, so that is, those are correct, so those are the first two. And now let's work with, let's see. Okay, let's work with pin D next. So pin D. So our free body diagram will look like this. So we know what CD is. We don't know what FBD is, And we don't know what, let's see, FDE is. So we have two unknowns and two equations, so we can definitely solve for this one. And this is angle 60. Okay, so I would start with, it doesn't matter which one we start with, neither is simpler than the other. Actually, I'm going to start with y. So this is equal to, so we have positive FBD, and this is in our, yeah, so all these are pointing the positive y direction. So this is FCD, and this will be so cos 60, and this is plus FDE cos 60. So FBD is equal to, so we already know what our value for FCD is, so it's 6. So 6 times cos 60 is equal 3. So this is negative 3 minus FDE cos 60. Okay, so we're going to come back to that one. And at x, so we have just 2, and they're pointing the opposite direction. So this is FCD, this is in the positive x direction, this is sine 60. And then we have minus FDE sine 60. And let's do, yes, we could solve for FDE here. So this is FDE is equal to FCD sine 60. We know what FCD is, and this is over sine 60. So we can cancel those out. So then FDE is just equal to FCD, which is equal to 6 kilonewtons. And this is in compression, right? Because they're both equal. So FDE, that is correct. And plugging this back into our BD, we have negative 3, and then, so that's plus 6 cos 60. And this will also be 6 kilonewtons. BD 6 kilonewtons, and this one is under tension. So this is negative 3 minus negative 6 cos 60. So it's negative 3. Oh, sorry, this is supposed to be positive 3. That would be y. Okay, there we go. Okay. So we've solved those two. Okay, and now let's use pin B. We're going to find this unknown here, because we know this other unknown, so this is, and we solved BD as well. Okay, this is FBD, FBC, and FBE. So let's just find FBE. So we only need our x equilibrium equation. This is negative FBE equals positive FBC. So that means FBE is equal to FBC, which is equal to FBC we found to be 5.2. .196 kilonewtons, and this will be in I'm not sure why that would be in tension. Okay, I believe this is going to be in tension because our other answer was in tension, and so since they're equal, then that would be the case. So I think this answer key might be wrong. Let me know if you think otherwise, and I can fix that. Okay, and our last one, oh wait, I know why. Sorry, I missed one thing. Sorry, this is my bad. So there's one more force like this at 30 degrees, and this is FAB. Okay, there we go, that would be why. So Fx equal to 0, this is equal to, so we have negative FBE plus FBC, and this is plus FAB, and that would be cos 30. Okay, so I'm probably not going to use this one to start off. I'm going to use our Fy. That will be simpler because we have one unknown, because we know what FBD is now. So it's FBD plus FAB, and that is sine 30. So FAB is equal to FBD over sine 30, which is equal to, so FBD was equal to BD, 6 kilonewtons, so positive 6, divided by sine 30, and this gives us 12 kilonewtons, and it's positive, so that's in tension, which is correct with our answer key. Okay, and to solve for our final BE, let's move this BE to the other side, and this is equal to FBC plus FAB cos 30. We have all those values. FBC is equal to 5.19, so this is 5.196 plus 12 cos 30, and this is equal to, hold on. Okay, so 12 cos 30, and this is plus FBC. Maybe I did something wrong. Okay, I see where I went wrong. This is meant to be negative. Okay, so now if we do that, this is, there we go. So this is going to be 5.196 minus 12 cos 30. Okay, and this gives negative 5.196. So FBE is in compression, so this is 5.196 kilonewtons compression. Okay, and our last one is from A to E. So I will use, it's orange right here. So pin A. Okay, and this is our last one. And since this is downward force, I'm only going to use the Fy equation. So this is equal to, so AE points down, it's negative FAE, and you have this one here, so you're going to find the y component of it. So this is 60. So this would be, cos 60. So this is minus FAB cos 60. And then FAE is equal to, so that's negative FAB, which was FAB, let's see. FAB was equal to, okay, let's just find it from our answer key. So that's 12. Oh yeah, here it is. So that's 12 cos 60. And this becomes -6. So FAE is equal to 6 kilonewtons compression. AE. Why is that 3? Okay, so in problem 2, we are using method of sections to determine CD, CF, and FG. So let's find that. So this is CF, CD, and FG. So we would have to cut this section here. Okay, we also need to consider our reaction forces. So we have AX, AY, and we also have a normal force of EY. So we're going to find those first. So let's find external support reactions. And we would just use these equations here to find the values that we need. So let's do moment about A. And we can work with that first. Let's start with moment about A first, because only considering our outside forces, at point A, we have the most things going through it, so it'd be easiest to take our moment about. So we use 6 kilonewtons, which is downward, and our horizontal distance, which is 3 meters. And you'd have to go clockwise to get there, so this is negative. Okay, this is -8 times 6 meters distance to A, and EY, have to go clockwise now, so that's EY times a distance of 9 meters. So if we move this around, EY is equal to, so this is 18 plus 48 divided by 9, and this is 7.3 kilonewtons. For our X, we have only AX, so AX is equal to 0. And for the AY, we have AY plus EY minus 6 minus 8, and that gives AY is equal to, so that's -7.3 plus 6 plus 8. 6 plus 8. And this would be AY is equal to 6.667 kilonewtons. And that is the right direction for it. So both these are pointing upwards. Okay, so our second part is now to draw our free body diagram. So draw truss. Okay, so I'm going to draw the right and left side. So this is our C. Then here's where we cut it. So this is FCD. This is FCF. And this is FGF. Okay, and we have our support reactions. All right, and we also have our 6 kilonewton force downwards, our external force. On the other side, we have this force pointing up, this one pointing out. Let's connect those two. We have 8 kilonewtons external force, and we have our reaction force from EY. So let's look at each side and see which one has the least unknowns. So on our right side, we'd have 1, 2, 3, 4, 5 unknowns. But on our left side, we have 1, 2, 3, 4. Actually, no, this we already know. Sorry, actually, we know our values for our support reactions. So that means each of these has 3 unknowns. So it just depends on which one you would like to do. So I'm going to work on the left side, sorry, the right side, but feel free to try the left side and see how it goes. So I'm going to use the right side. So let's start with our moment at F equals 0. So this gets rid of CF and CG and our 8 kilonewtons. So we only have FCD at a distance vertically of, okay, we actually don't know our vertical distance. Let's find it. So we want this distance here. So this is 3, and we have 3 here. So this is like saying we want this distance here. This is 3 and 3. So we can say cos. Actually, no, we can use Pythagorean theorem to find this. So 3 squared is equal to a squared plus b squared. So this is 9 equals 9 plus b squared. Sorry, please forget that. This is, let's instead use this. This is 30 degrees. So this is 3 cos 30 for our height. So let's put that in, 3 cos 30, right? And we would have to travel counterclockwise, so that is positive. And this would also be positive for our EY. EY we found to be 7.333 at a distance of, so we want our horizontal distance, which is 3 to get to pin F. And FCD is equal to, so it's going to be a negative value, so this is times 3 divided by 3 cos 30. And this is equal to negative 8.467 kilonewtons, or it's equal to our magnitude with direction. So 8.467. So that is our first one for FCD. Okay, we're going to keep going. So let's do our FX. Actually, no, I'm going to do FY first. So I think we have less going on. So we have positive 7.333 plus 8 kilonewtons plus the FCF value. And since these are equilateral triangles, each of these has an angle of 60, sorry. So that leaves our 60 degrees here. So this is FCF, and we want the sine 60, which is our y component, and we get FCF is equal to negative 7.333 minus 8 over sine 60, which is equal to, so negative 7.33333 minus 8 divided by sine 60, and this is equal to negative 17. Oh, sorry, this is supposed to be minus 8. So this is plus, there we go. Sorry, I'll try that again. This is negative 7.3, and this is plus 8. That's divided by sine 60. And this is negative 0.769 in tension. Okay, so that is our CF solved. And finally, we will solve for FG. So we have FGF in our negative direction minus our FCF in a negative direction, which is cos 60, and then minus our FCD so that makes FGF equal to negative FCF cos 60 minus FCD, and that is equal to 8.08 kilonewtons. It's positive in tension. Okay, so that is how to use method of sections for simple trusses. All right, okay, so problem 3. This is going to be our last one. I'm going to skip over problem 4. I'm going to leave problem 4 for you guys to do on your own. We're going to use one more question that involves our method of joints. So let's see if we have any zero force members. So we're going to use pins B, E, C, and D. We know at pin E we have an EY reaction. And the reason we're not using A is because we have 2 reactions here, and we can just minimize the amount of work we need to do by not including that in this one, right? Because it will be solved using the other pins in this case. So let's start with B. So this is angle of 60 degrees. Okay, and this is FBC, FBE, and FBA. All right, so let's start with this question. Let's start with our FY, because then we'll only have 2. Actually, no, I don't want to start with this pin because we have 3 unknowns and 2 equations to solve them. So that means it'll be a little more difficult to move on. Let's instead start with point D. Because then we have 2 unknowns because we have this force P, which is 8 kilonewtons. So this looks like, this is 60. This is FDE and FDC, and we have downward force of 8 kilonewtons. So let's find Fy. So this is, so we have negative 8 pointing downwards, and then we have the y component of FDC pointing upwards, and this is sine 60. So FCD is equal to 8 over sine 60, 8 divided by sine 60, which is positive 9.24 kilonewtons, and it's positive, so it is in tension. Okay, so that is our first one done. And for our Fx, we will do FDE, that's pointing in our negative direction, and so is our FDC, cos 60. So then FDE is going to be in compression, so this is FCD times cos 60, and this is 4.62, and it would be negative, so this is in compression. Okay, and that matches. Okay, next let's look at, I would look at pin C. So pin C is equal to, so it gives us these three, but we know what this one is, so FCD we already have. We're looking for FCE and FCB. Okay, so let's work with that now too. This is 60 degrees, and so is this. Okay, so I would start with our x. This is negative FCB. And this is minus FCE. It's cos 60. And this is plus FCD cos 60. So we can solve for CB in terms of FCE, which is negative FCE cos 60 plus our FCD. FCD was 9.24, so times cos 60 is equal to 4.62. So for our Fy, we're going to have two unknowns. So this is negative FCE sine 60 and negative FCD sine 60. So let's solve for FCE. So FCE is equal to our negative FCD, and our sine 60s cancel out. I'll show it anyways. Both those cancel out. This is 9.24. So FCE is equal to negative 9.24 or 9.24 in compression. So that makes FCB equal to, so it's 9.24 cos 60 plus 4.62, and this is 9.24 kilonewtons in tension, because it is positive. So we've got BC and CE. Okay, and let's work with pin B now. So for pin B, it will look something like this. This is 60, and this is BA and FBE. Okay, so let's start with our Fy is equal to 0. So this is negative FBA sine 60 minus FBE sine 60. So we don't know these values yet, so this is FBA is equal to negative FBE, because our sine 60s cancel out. So let's work with our y then. Oh, sorry, I said I was going to do x first. Or was that y? No, that is y. Okay. So now let's do sum of fx, which is equal to positive FBC, which we know. And this is plus FBA cos 60. Sorry, this is minus. And this is plus FBE cos 60. I'm going to keep writing down here. So let's find what FBA is equal to. So we have FBA is equal to FBC plus FBE cos 60 over cos 60. Okay, and let's plug into the sum of Fy equation for this. So FBA is equal to, so let's put this on the other side, let's make them equal to each other. This is our FBA, and we're making it equal to negative FBE. So this BE. Okay, so this is FBC over cos 60 plus FBE, and both of our cos 60s cancel out. So this is negative FBE. Let's move this over. So we have negative 2 FBE. So we move the FBE over. Okay, and this gives us, okay, we know what FBC is. FBC we found to be 9.24. So this is 9.24 divided by cos 60 divided by negative 2. And this is 9.24 for BE. So FBE is equal to negative 9.24, which is equal to 9.24 kilonewtons in compression. Okay, so there's that one done. And then let's go back to FBA. So FBA is equal to negative FBE. So then FBA is equal to positive 9.24 kilonewtons in tension. Okay, so that's that one done. And now with pin E, we want to find AE. So we need to find our reaction first for E. So I'm going to use our only external forces about A because we have two reactions there. And this will be EY, and we'd have to go counterclockwise. And this is at a distance of 4. And we would need to go clockwise for our 8 kilonewtons. Go 8 meters to get there. So then EY is equal to 8 times 8 divided by 4, which is equal to 16 kilonewtons. And if we sketch out what E looks like, so our free body diagram, we have lots of different components, but our only unknown is this one here. So when we write our equations, this is Fx equals, so this is negative FAE, this is positive FED, which we have. We have positive, what is this? This is FEC. And we want, this is cos 60, and then minus FEB cos 30, cos 60. So we can get FAE equal to, so let's add all of these together. So ED was negative 4.62, and this is plus FEC. FEC is negative 9.24 cos 60, and this is minus EB, which is negative 9.24 cos 60, and this gives 4.62 kilonewtons in compression. Okay, Okay, so that brings us to the end of this question and these examples in this problem set. So I'll scroll down and have you try problem 4. I'll give you a little hand. This is a zero force member, right? And you're going to use method of sections to find CD, HI, and CJ. So use your knowledge from the notes videos and these practice problems to help you solve this, and the solutions are right there as well. All right, I hope you enjoyed this video. I hope it helped you, and I will see you in the next one. Thanks for watching.